Welcome everybody. I would like to introduce the first session, but before that, I would like to introduce all of you the interactive format via chat that we have here. If you have any question for the presenter during the presentation, please don't hesitate to write it in the chat, and then I will just read it to the presenter, and then we can have a more dynamic conversation. Well, being that said, I will just directly move on to introduce the presenter for the use case number 4, Mahmoud AbdelAziz, founder and CEO of DevisionX. Mahmoud has more than 8 years of experience in machine vision, in artificial intelligence, robotics, and smart manufacturing products and projects. He started his first startup, QI, in 2013 that built machine vision solutions for the textile industry, and in 2016, he founded DevisionX to build quality inspection systems using a mix of machine vision and AI. Today, Mahmoud will be talking about their latest product, TUBA AI Machine Vision enabling tool, label, train, and integrate. Good morning, Mahmoud, and thank you for being this morning with us.
Yeah, good morning, Andrés, and thank you too for your intro. Good morning, everybody. Just give me a minute to share my screen.
Mm-hmm.
So you see a screen now?
It's loading. Now we can see the screen. Okay. You can start.
Okay. Hello, everybody. Thank you for attending my session, and I'm happy to with AI Guild and AI Datalift. So my name is again Mahmoud AbdelAziz. I am founder and CEO of DevisionX. We'll start this session. We'll go through about machine vision system and AI and what we can do with these tools in manufacturing sector. So if you are not aware of machine vision system, you will find here, consider it something like plastic or textile sheet, something like that. Machine vision system consists of a set of cameras, different types of cameras may be installed here, lenses, lighting, and control system. All these hardware sets, you can consider it as a body of the system. Computer vision part is how to receive the images or video stream from these cameras and make the required analysis to check the quality of this product according to each type. So we consider here machine vision is a body of the system, and the computer vision is the retina or optic nerve that analyzes the images or video streams. So what is the problem that we are trying to solving? Problem of quality inspection in general in any manufacturing field or manufacturing entity. They make it maybe a human inspector that lead to low accuracy, high operation cost, and also unused large amount of data and unstandardized reports. So this lead to maybe low quality products, diversity in quality level between us and the others, and there's a big problem and effect on the business itself. So what we are doing in DevisionX, we automate the quality inspection process and make it real time and lead to real time data management, standardized reports and the custom report. Also adding AI or deep learning part lead to high accuracy and make it flexible for different type of products in the same industry. Okay, here why we are adding AI or deep learning to machine vision. In this photo, consider it in the left part, traditional machine vision algorithms. So you will find that we'll take a picture, make feature extraction, make a decision based on it. So if you change anything on the input or in the feature extraction, the decision here will change. So it is a very constant algorithm. Need to build more and more algorithms if you change the image type or the product types. So it is not flexible at all. And it's a traditional one. But after adding AI to this part. It's made more easy and fast in production, and also flexible for different type of products. We just have a model. We train the model according to the input photos, and then generate a trained model based on these photos that can make a prediction or take a decision based on these photos. This makes the manufacturing itself can apply the same model, or after training it, just retrain the model with different type of products in the same sector or in different sectors. So we have many flexibility in applying machine vision systems. And this is just an example. Consider it maybe textile piece. So textile piece have a different type of defectors, but textile may be plain, something like that, or a patterned textile. For plain, it's okay to build algorithm for this. So consider that you have different type of pattern of textile. So you need to have different type of algorithms to detect the defects of this pattern textile. This is for the traditional one, but after adding deep learning, and actually this is a real use case, after adding deep learning, so we can train the model on different types of textile, patterned or unpatterned, and it can detect the defects very quickly, very easy. You need to or make algorithms again, just to train a model again. So we have different type of operation here, classification, just to predict is defected or not photos like this. We have detection to just make a detection or square on these defects to have the place of these defects. Segmentation, just to segment the defect itself from the background. And also it is good if you have more than one defect per image. So this is a different type of operations that can be done using deep learning models mixed with machine vision too. So why we need to make this? It is the ROI for the business itself. So it's high quality. We increase the quality of the products, so which means increasing the prices. Better quality strengthens brand reputation. If they have this type of systems, so they have big data plus AI, so they have helpful insights, increase the ROI. Also, they will have different gradings or different qualities, which mean different prices, and will reduce the human factor error that results from using human inspection. So this mixing of ROI or some benefits, business benefits for the manufacturing enterprise. So now we will go to different use cases from different manufacturing sectors. We'll start with food and beverage. We have different applications in food and beverage. For example, sorting parts, so to make sort based on color or shapes or defects, something like bread sorting here. And also we have a very common application in sorting especially for vegetables and fruits, sorting based on size, color, and outside defects. For example, here gouging and packaging to check the sealing of bottle caps, something like that. Also checking the printing and data printing on packages, and especially for expiry date and other important data. For pharmaceutical, we have a common application called the track and trace to track the QR codes on medicine packages. Also inline printing inspection, artwork inspection for printing, also packaging inspection, and accounting and sorting too. In automotive, we have very different diversity of applications, like steel welding inspection, based on welding inspection too. So we have the welding inspection, especially based on X-ray inspection. It's very important in automotive. Gouging and the measurement of dimensions of main parts, also, and about train assembly, coating, something like that, coating inspection, and also codes and stamping inspection. We'll go to semiconductors and electronics. the common feature here in a semiconductor is the speed of inspection results to a speed of production. So we use here very high frame rate cameras to, for example, make PCB quality inspection, soldering inspection, wafer inspection, and barcode inspection and packaging inspection too. We'll go quickly to plastic. It's the same of automotive. Near to that, something like gouging and thickness dimension of plastic, surface inspection, especially surface like that to inspect some defects in plastic sheets defects. We may use here infrared cameras and also BBT code and data confirmation inspection too. Now we will go through a high real case with companies. We have company here in called the Midwest, is a plastic companies in USA. They are producing plastic packaging and printing plastic packaging like this image. So all this they were doing before this system. They have operator take sample of the production line and make a check by his eye that lead to more time in production and also not consensus quality standard. So they replace it by using line scan cameras, LED line scan lightning, and industrial PC to make the processing. And now it is fully automatic. No need to stop the production line and they take the sample for inspection. After installing this inspection system, so system paid for itself after 6 months and reducing the production material waste that represent 60% of the cost. So we have now a very fast ROI of using an inspection system instead of human inspectors. Now we'll go some examples from big corporation, multinational corporates, and see how they have the very high volume of inspection systems that lead to some change in the industry itself. For example, in General Motors, they have 2,000 plus smart cameras, 2 million plus inspections per day, 1 million plus data sets uploaded daily. So they have a very, very high volume of data and images uploaded daily. So it is not one system and it's done. No, it's very, very big volume of data. They have different types of applications, different from complexity, from low to medium to high. For example, in low, they make it for error detection and part signaling, part presence, something like that. To the high complexity systems like 3D tracking, 2D locating, surface inspection quality, surface mapping, and something like that. There's some types of their different types of application according to the automotive production line. So in this case, they have some barriers and the challenges want to improve to have more and more smart systems using it. First one, for example, improve the image compression. So we have a very large volume of images, so need image compression solution to be used to image transfers. By the way, image compression will affect on the image quality, will affect on the trend model accuracy, but it is a need for storage. Second one is more automated image analysis. For example, they need to more automated systems to make analysis and automated in development part. No need to develop everything from scratch. And also, they have, and we will go through the emerging and the future technologies that they need to have a closed loop of analytics automation across devices. So when the system is installed in the production line, it will have a new images and the new photos of defects. So it need to go back and defeat the system itself again and update the trained model. And also deep learning on distributed system, something like smart cameras and AI on the edge. No need to put AI on cloud. We need to put it beside the machines and the production line on the edge. So there's some barriers that we have, and they need a solution or a new approach to solve some barriers. the same barriers have in B&G. You know, B&G have very different types of home and personal products. So also they need a getaway from customized solution. No need to build a customized solution anymore, but need to enable mass adoption of vision technology. So it's something like configure with re-engineer. We need to re-engineer the models or the current system to work on different types of products. No need to get to a technical company provider and build system from scratch again. Also, make the system simple as using apps on smartphone. So it is called as how to make it more and more simple. And also in the AI needs in the AI and deep learning allows system to learn and adapt, move away from rule-based system and self-learning system. It's something like why they in a need to automate the development part, make it more flexible and also make it more simple for the non-AI expert or non-developer user to use it. For this, all this reason, we go to TUBA. TUBA is a no-code AutoML tool to enable the manufacturers themselves that they are not AI expert or not a developer to build their deep learning model by themselves. So they can learn their images, train it, and integrate it with current or a new machine vision system without any experience in coding or AI experience. So consider it with me. This is a traditional ML process. So if you are a machine learning engineer or data scientist, will go for sure you are aware of this process. We'll go all this process as a traditional one, but in our or AutoML concept, no need to go all this phases. So just data acquisition and then make the predictions. All this process make automatically. And this is the concept of AutoML, and all the manufacturing sector and any other sector too going on this direction now. So simply, how we integrate? Just you have your images. Maybe it's images unlabeled, so it is different types of images together. Just label these images and then make a training of self. And the training, you're choosing the types of operation, classification, or detection and segmentation. And maybe we have detection and segmentation together, so it is possible too. Then you export your model according to your needs. So we have different types of model exporting. Also, you can export it as API, so just you can have a link and integrate it with, for example, with your mobile app, as example. And also, you have a testing dashboard, so you can upload new images and test your model and test its accuracy. These models can be integrated easily with different types of software and also hardware. For example, this is a new family of cameras called the deep learning-based cameras. So the user can go through this process and then generate the model and just put it on the camera, and the camera now will take the images and make analysis and then generate a control or a result signal for the user. So now we have end-to-end solution from the data or the raw images and to the camera itself. Now we have automated all the process, so the user or the normal user, maybe a quality engineer, production engineer, can use this process as a no-code tool and make it by themselves. So just TUBA, we have this tool now that can be on cloud and also on premise on the manufacturer server. That can be integrated with deep learning enabled camera and also with software app and solution, any different type of software applications. So we have now generated to end solution that can be machine vision system on the manufacturing line, or also can be computer vision software or app. So why TUBA? Why we need something on this approach? So it is AutoML end-to-end solution, different type of deployment option, no coding, on cloud services with monthly packages. So if you need it just for 1 month, you can make it. And also on premise, if you need to keep your data on your entity or on your server, so we can provide it on premise. and also affordable price according to subscription and software license. So thank you very much and I am here for your questions.
Thank you very much for the presentation, Mahmoud. It was really interesting. Now we only have 9 minutes left to move on to the questions time. So I would firstly let you know that this session is being recorded and that you only would be turn on your camera if you're okay with being recorded. And now I'll try to fish some questions in the chat. So please feel free to write them down there. And I do have questions after seeing this, so I can start maybe, and then someone might follow. So as I have understood, TUBA enables currently existing machine vision systems to use deep learning models using the data previously collected from that system, right?
Yes.
Okay, so how do you perform the data labeling? Do you label it yourselves or you rely on third companies?
Okay. Actually, we make it by ourselves if we are the users, but we provide the user a tool that through TUBA that the user can make the labeling. So they make it by themselves. They have something like a screen. They have the image passing on it, and the user can label its image. Is it, for example, good or bad? As example. So the user can make it by themselves. Yeah.
Okay, so you basically, the user gives you the data labeled, and then you work with that.
Yeah, they are different approach. The user give me the data labeled if I am not using TUBA, but for TUBA he can give it. They have a raw data not labeled, and he can label it by themselves. Yeah.
Okay, then. Another question that being this productionized data lift, what was the major challenge in deploying this type of system?
The major challenge is the computing power. Some type of system need high computing power, like very high price GPUs. It's according to the high rate of taking images. For example, we may lead to using cameras using more than 120 frames per second or more. So we have a very high volume of images per second, so that need to a very high computing rate based on GPUs that increase the price.
Of course, I can see that how that can completely affect the final price. I've got a question here from one of the users. Sarah is asking now, from the customer point of view, what is the main difference between using no-code AutoML tool like TUBA and requesting AI machine vision system from a system provider?
Actually, we are making both, or we are making the customized one. So if without TUBA, the customer can come to us and have a challenge or a problem describing it, and we study it and build the system based on their problem. Even it is classic machine vision or also is based on AI. So we will see that we build a new system based on a new customer. It is a non-scalable model at all. But when using TUBA, we just give the tool to the user. The user can use it by themselves. So they can just have their images, make the labeling, and they choose the training. For sure, we can give support for the user and then generate the model by themselves, then can be integrated with cameras. So in the first model, you can call that we as a technical provider or system provider, we provide 100% of the system. In the second model, we can provide just 30% of the system as a type of support.
Okay, we have more questions here. One from Gia. She's saying, how long does it take to give back the solution to the company after submitting the data? Which is the same question that Sentinel Academy has.
Actually, it's according to the data type and data volume. We don't have a standard time for that, but maybe we can, the average of generation deep learning model maybe if you have a ready data, so it can be less than 1 week, maybe 3 days, according to the computing power here.
That's pretty fast, I would say, but yeah, of course. I would encourage everyone to keep posting the questions so I can read them. But the question from Sentinel Academy was kind of the same. What is typical time period for the TUBA tool deployment? Basically, that doesn't add any new information to the conversation, I think. We have 4 more minutes. If there's any other new questions. Regarding SLA, and there's a new question coming. I cannot understand it. We have still.
No. Yeah, I could SNS too. Yeah. I think I have a question sent me briefly. It's called how much label data required in general to build a high accuracy model. It's actually to answer this question, it's different according to the operation, the classification or detection or segmentation. But we till now we have maybe 100 photo per class, especially for classification. It can be less according to the nature of the operation itself.
Mm-hmm. Okay, here there's a question, Mara, explaining example, how do we get support from Malaysia? I would say that you directly contact Mahmoud in their LinkedIn. So you can actually, this type of questions you can ask him directly. I would leave his LinkedIn profile as well as mine, so everyone can reach us. And I would say that if there's no other question, I can start finishing the session session right now. I would just say that thank you very all for attending. Thank you, Mahmoud, for the very interesting presentation, and everyone that engaged into the chat. I would like to remind you that the next data lift number 3 will be live on Friday, 24th of January at 11 a.m. CET again.